Find the perimeter of quadrilateral ABCD. So, with this problem right here, we need to find the perimeter of quadrilateral ABCD. Right here, I'm going to use the Pythagorean Theorem. The reason why I'm going to use the Pythagorean Theorem, I believe it's much easier to use the Pythagorean Theorem when they give you the graph, and distance formula is more efficient when they give you just the coordinate points. Alright, so we need to find the following. We need to find AB. We need to find BC. We need to find CD. And we need to find DA. I'm going to highlight to make sure I cover everything. So AB, I'm going to highlight orange. Then I'm going to highlight BC is pink, purple. Then I'm going to highlight CD, green. And then finally, I'm going to highlight AD as, oops. Alright, so one of the first things you should always do when finding the perimeter of polygons is to see if there's any vertical or horizontal distances. And right away I can see slant, 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 and this is vertical. So that's perfect. So we can count the distance without even using the Pythagorean Theorem. Starting a point doesn't matter where you start, but you need to start, the starting point needs to be 0. So right here, that's 0. 1, 2, 3, 4, 5, 6, 7. This right here is 7 units. Let me just double check here in a second because you are prone to make a mistake. 0, 1, 2, 3, 4, 5, 6, 7. So we got that part. So we're already doing pretty well. So like I said, we're going to use the Pythagorean Theorem. Pythagorean Theorem. Looks like this. A squared plus B squared equals C squared. A and B, the order doesn't matter. But here I'm just going to say this is for the vertical, or horizontal, I mean. This is the vertical. And this is the distance. It's a little small, but horizontal, vertical, distance. Just to keep it consistent when doing these. First on the list is going to be AB. So we're going to get AB done. So first we said it's going to be horizontal, so I'm going to start on point B and then go all the way down to this point. Starting point 0. So 0, 1, 2, 3. So our horizontal A is 3 squared. Now we need to do a vertical distance. 0, 1, 2, 3. We have to count all the way up to A. 0, 1, 2, 3, 4, 5, 6, 7. That's going to be 7 squared, which is equal to C squared. 3 times 3, 9. 4 times 4, 49. Equals C squared. 49 plus 9 is going to be 58. Equals C squared. From here, you square both sides. Square both sides. You get the square root of 58. Is equal to C. I want to leave it like that for now. Actually, let's just see if we can simplify. 58. 58 divided by 2, 29. 29 is a prime number, so we're done. We're going to leave it like this so we can get an exact answer, and we don't want to round to the very end because we want to make sure our answer is exact as it can be. So right here, we have square root 58 units. Next on the list, just cross that out. Let's do BC. All right, so BC, let's first count from here. to here, let's do our horizontal distance. So here, that's our starting point. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So right here we have 8 squared. Just one more count. 0, 1, 2, 3, 4, 5, 6, 7, 8. Now we want to count from here to point C, which is just 1. So it'll be 8 squared plus 1 squared equals C squared. 64 plus 1 equals C squared. 65 equals C squared. Square root it. Square root it. Emma. So right here, we have 65, square root 65. That's enough. Is equal to C. 65 is broken down to 5 and 13. It's by primordial, so we can't do anything. So then we're going to put for BC, 65 square root units. We're just going to keep it like that, not get a decimal right away, because we want to make sure our answer is as precise as possible. Last, we want to find DA, or AD, doesn't really matter. So, our horizontal distance will be our first thing. I'm going to start at A here and then count to D. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 11 squared, 11 horizontal distance. Just triple check it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then from this point, you're going to count up 1, and you get plus 1 squared equals C squared. And to finish us off, 121 plus 1 equals C squared. You have 122 equals C squared. You square root both sides. Square root both sides. You get square root 122 equals C. I don't think you can simplify 122 much. 2 and 61, 61 is prime, so it can't be simplified, so we're going to leave it like that. So we get square root 122 units. And let's work out the exact answer, and then let's get our estimate. An exact answer would look like this. We would have all these added up. So it would be square root 58 plus square root 65 plus square root 122 plus 7, put parentheses so we don't have to do as much, and then put units. Alright guys, I'm almost done. To get your exact answer, we can start it off right here. 58 square root plus 65 square root plus 122 square root plus 7. And we would get roughly, as an estimate answer, would be 33.72 units. Before I conclude, I just want to check my work that we got it right. 58 square root plus 65 square root plus 122 square root plus 7. 33.72 is it on the dime. There you go.